rules for addition, subtraction, multiplication and division. We already know that there are significant figures and to the rules for significant figures. If I am adding different measurements, as I said, we do multiple measurements, not one measurement. Supposing we are adding different measurements, then what is the rule? The rule says that if I have more than one measurement, if I am adding, I am subtracting, I am multiplying or I am dividing, I will report my answer with the least significant figure. The measurement which has the least significant figure is where I will report my answer. Let me see the example of this. Let me add 2.314 in 4.3. 4.3. Now here 4166, but this has only two significant figures. This measurement has got 1, 2, 3, 4 significant figures. This measurement has got 4 significant figures. This measurement has got 2 significant figures. Answer will be reported with the least significant figures. Therefore, I am cutting this point here, that my answer here is 6.6 because it has 2 significant figures. Because this digit has got minimum significant figures, my answer will be in this. If supposing the number was something like this, 2.374 and 4.3. If I am adding the two, this I was adding the two, it becomes 476, 6.67. Now again the number has to be reported in 2 digits, but you find that this number is greater than 5. Therefore, this number has to be rounded off, and in the rounding process, this will become 6.7 as my correct answer. This is addition. Same rules apply for division also. For division also, for subtraction also. I subtract 5.798 from 2.3 minus. The number is 74398. But this has got 2 significant figures, 2 SF. This has got 1, 2, 3, 4 SF. I have to report my answer in minimum significant figure measurement, that is 2. So this I am cutting off here. I am cutting off here. But the problem is that this number, you can see, this number is more than 5. So in the round off process, this will become 3.5 as my answer. Therefore, we can also multiply the number. Supposing I am multiplying 3.5 into 2.521. This has got 2 significant figures. This has got 4 significant figures. And my answer should be in 2 significant figures. Let me see in my calculator the value which I will get. I have 3.5 multiplied with 2.521 equals to 1.8235. But I have to report it only to 2 significant numbers. These are not required. But here this value is less than 5. The answer is 1.8. Now I am going to make a division. 0.52. If I divide by 14.785, this is non insignificant 2 SF. 1, 2, 3, 4, 5 SF. So answer should be reported in what I am saying. Answer should be reported in 2 SF. This value, let me see by division. 0.52. I am dividing by 14.785. This is coming to be 0.0351778. How many significant figures I want? I want 2 significant figures. 2 significant. Therefore, this is not significant, this is not significant. The two significant means I have to get only up to this. These are not required. The answer therefore comes to be 0.0. This number is less than 5. Therefore, in rounding off, this number stays. So this has got two significant figures. This is my answer. Therefore, in division and multiplication, our rule is very simple, that we will report our answer so that the measurement with the least significant figure is reported in the final answer, not more than that. Let us see if we can solve some questions on this from your NCERT book. NCERT book. Questions from NCERT on this. First question, express in scientific notation. 0.0048 234000 8008 5 6.0012. Now this number, you can see that scientific notation means, we have told you what is scientific notation. Number is expressed in this form. This number is between 1 and 10 and this is an integer. Now here the number between 1 and 10 will be 4.8, means 4.8, and express in scientific notation, I have to do it. What is the result of this? This is 4.8. I am going from this number 1, 2, 3, 1, 2, 3, 1, 2, 3, from left to right, left to right. So this will be 4.8 into 10 minus 3. This number is between 1 and 10. This is an integer. Now here I have to go 2.34. 2.34. 1, 2, 1, 2, 3, 4, 5. 5 digits I am going. Therefore, from right to left. From right to left. This becomes 10 power 5. This number, similarly, on the same rules, I am reporting 8.008 into 10 power, how many? 1, 2, 3. Right to left. I am going from right to left, 10 power 3. Then, this number, this has got 4 significant figures, as you can see. So, I am reporting in this 5.000 into 10 power, how many digits I am moving? 1 and 2. 10 power 2. Here, this is already between 1 and 10. 1 and 10, therefore 6.0012. This is our scientific representation of the numbers. Let me see the next question. How many significant digits are there? First, 0.0025 208 5005 500.0 2.0034. Let me use the rules for this SF. Numbers preceding zeros are not significant. This is not significant. This is not. There are only 2 significant figures. Here the 0 is between 2 non-digit significant. 1, 2, 3. 3 significant figures. Here 0 is between 2 non-zeros. 1, 2, 3, 4. 4 significant figures. Now here the 0 is, there is a decimal. After the decimal there is a 0. All become significant. 1, 2, 3, 4. 4 SF. Here all are significant. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 SF. Therefore, by using the rules of significant figures, we can solve this question also. Now we are coming to another question. Question 3. Round off. Round up to 3 significant figures. 34.216, 10.4107, 0.04597 and 2808. Round up to 3. 1, 2, 3. 3 significant figures. Now this digit is, the number is 34.2. This number is less than 5, so this number stays. In this case, round to 3 significant figures. 1, 2, 3. 10.4. 3 significant figures. This number is less than 5, so there is no change. In this case, these are not significant. This is not significant number, so I have 4, 5, 9. But this number is greater than 5. This number is greater than 5. So this number will be increased by 1. When it is increased by 9 plus 1 is 10. 6, then it becomes 0. So what we get is 0.0460. This has got how many significant digits now? 1, 2, 3. These are not significant. So 3 significant numbers. If I have to round up this in 3, I have 1, 2 and 3. This number. But 8 is greater than 5. So this has to be increased by 1. So it becomes 2810. 0 is a number after there is no decimal. Therefore this is not significant. Therefore the answer is 2810. Let us see another question. Question 4. Convert into basic units. 28.7 picometer, 15.15 picometer, 25365 milligram. What is a basic unit? I told you there are 7 basic units, and for length meter. So 28.7. 1 picometer is nothing but 10 minus 12 meter, and express it in the scientific form. This becomes 2.87. So what happened is that I have moved from right to left. Therefore it becomes 10 minus 11 meter. Now here again 15.15 into 10 minus 10. If I express in scientific notation, I will move 1 digit here, so which is 1.515 into 10 minus 11 meter. This I am expressing in, I have to express in kilogram, but I am saying 2.5365. 1, 2, 3, 4 digits I am moving from right to the left, into 1, 2, 3, 4, 10 power 4 gram. But gram I have to convert into kilogram. And you know that what is the relation? Kilo is 10 power 3. 1 kilogram is 10 power 3 grams. So 1 gram is 10 minus 3 kilogram. 2.5365. 10 power 4 into 10 minus 3 kilogram. So that comes to be 2.5365 into 10 power 1 kilogram. 10 power 1 kilogram. So what we have expressed is we have converted them into basic units, into the basic units. It was 2.5365 milligram. So 10 minus, it was 10 minus, there is some mistake here. Converted milligrams. This was milligram. First I have to convert, this was, some mistake is here. This is 2.5365 into 10 power 4 milligrams. If I convert milligram into gram, it becomes 2.5365. 10 power 4 into 10 minus 3 gram, 3 gram, which is equal to 2.5365 into 10 power 1 gram. If I have to convert gram into kilogram, 2.5365 into 10 power 1 into 10 minus 3 kilogram. So the answer is 2.5365 into 10 minus 2. So this is the correction in the term which we have said. So what we have shown here, that no, we cannot perform any measurement with 100% accuracy. It is not possible to get exact value. There is an uncertainty involved in every measurement. And in order to get good measurements, what we do is we try to make multiple measurements instead of one. And after that, we said that we report these digits in significant figures, and the last digit is usually the uncertain digit, and we want that our calculation should be more accurate and precise. So it will depend on so many factors, what type of instrument which we use for measurement, and the other external factors like temperature, pressure, or things which are changing. And you have been told there are systematic errors and random errors, and we have shown the calculations also, how we can add and subtract numbers, and what are the rules for significant figures. I thank you all, and in our next lecture, which will be connecting with this, we will be talking how we can convert one system of unit into another system of units, because that is also very important, that what type of units we have. As I said, there are 7 basic units, but we express our quantities in different units, and this calculation will be very important. And I will see you in my next lecture, in which we will convert one unit form into another unit form. I always say that you can keep on working, and stay focused on your syllabus, on your course, and make sure that you don't waste your time. Okay, bye, see you next time.